We're going to be using indirect measurement for scale drawings and scale models. You're going to learn to make comparisons between and find dimensions of scale drawings, models, and actual objects. Scale drawing is a two-dimensional drawing that accurately represents an object. The scale drawing is mathematically similar to the object. So a good example would be when an architect draws down a floor plan for a house. It's not the exact size of the house because it's on paper. It's a scale drawing. It's a reduction of what they're actually building. So that's the most popular usage of this. A scale gives the ratio of the dimensions in the drawing to the dimensions of the object. So for instance, it's twice the size. 2 would be the scale, or it's half the size. Half would be the scale. All dimensions are reduced or enlarged using the same scale. Scales can use the same units or different units. So here's an example. 1 to 20. 1 unit on the drawing is 20 units. 1 centimeter to 1 meter. 1 centimeter on the drawing is 1 meter. You use that a lot in maps. 1/4 an inch is equal to 1 foot. 1/4 an inch on the drawing is equal to 1 foot. So, everybody knows that 1/4 an inch is not the same size as a foot. This is a scale. If you had a line that was 1/4 an inch, it would represent a foot. Using proportions to find unknown scales or lengths. Here's an example. The length of an object on a scale drawing is 2 centimeters, and its actual length is 8 meters. The scale is 1 centimeters to how many meters? What is the scale? You would set up a proportion using scale length over actual length. So the scale length is 1 centimeter to blank meters, and that's equal to the drawing scale, which was 2 centimeters to 8 meters. And you solve this the same way we've been solving these. Find the cross products. 1 times 8 and x times 2, so 8 equals 2x. You divide. That's how you solve. Divide by 2, and you get 4. So 1 centimeter would be equal to 4 meters on the drawing. The scale A to B is read A to B. For example, the scale 1 centimeter colon 4 meters is read 1 centimeter to 4 meters. Here's your check it out. I want you to give it a try. The length of an object on a scale drawing is 4 centimeters and its actual length is 12 meters. The scale is 1 centimeter to how many meters? What is the scale? Press pause. I want you to attempt this. Set up the proportion using scale length to actual length. So we're asking 1 centimeter is to how many meters. The space that's empty, because you can't see it for some reason, is 4 centimeters to 12 meters. Find the cross products. 1 times 12, x times 4. 12 equals 4x. The inverse operation of multiplication is division. So we divide by 4, and we get 3. So the scale is 1 centimeter to 3 meters. Here's an application. Under a 1000 to 1 microscope view, an amoeba appears to have a length of 8 millimeters. What is its actual length? Scale length to actual length. 8 millimeters to x millimeters. 1000 to 1. 1000 times x, because you find the cross products, equals 1 times 8. You end up with 1000x equals 8. And they broke it down. After they did 1000x equals 8, they divided by 1000, because that's what was attached to the x, and got 8 thousandths. The actual length of the amoeba is 8 thousandths millimeters. So here's your check it out. I want you to try it now. Under a 10,000 to 1 microscope view, a fiber appears to have a length of 1 millimeter. What is its actual length? So press pause. I want you to try this one. You need to set up your proportion with scale length over actual length. 10,000 to 1 is our microscope view. It's going to be equal to 1 millimeter to blank millimeters. Cross multiply. 10,000 times x is 10,000x. 1 times 1 is 1. Divide by 10,000. And you get 1/10,000th. So the actual length of the fiber is 1/1000th millimeters. A scale model is a three-dimensional model that accurately represents a solid object. The scale model is mathematically similar to the solid object. So here's your example of what we're talking about with scale models. We're going to be finding unknown dimensions when you're given the scale factor. A model of a 27-foot tall house, so it's a three-dimensional object, was made using a scale of 2 inches to 3 feet. What is the height of the model? So we're basically building a tiny little house that replicates a real house. So to get started, you of course are you're going to think the model is in inches. Since we're looking for the height of the model, everything needs to be in inches. If we were given the dimensions of the model and needed to find the house, then it'd all be in feet. But since we really want the tiny house, we're going to want everything in inches. You're going to write down what you need. We need the conversion factor. 1 foot equals 12 inches. Where do you find conversion factors? On your formula chart. Now we're going to set it up. So I'm going to change the scale 2 inches to 3 feet first. I need to get rid of that feet down at the denominator. So I multiply it by the conversion factor, 1 foot to 12 inches. I put the feet on top, so that way it's across from the 3 feet, so I can get rid of it. Then I'm going to multiply straight across, because that's how you multiply fractions or ratios. 2 times 1 is 2 inches, is all that's left up there. 3 times 12 is 36 inches, because that's all that's left down there. The numerator represents the model. The denominator represents the actual house, because remember, inches to feet, the whole point in having the feet was to have the house. So we need to know that, because whenever we go to set it up next to the house, it's going to be important. So the house is 27 feet tall. I knew to put it on bottom because the denominator represents the actual house. So the 27 feet goes on bottom. We don't know how many inches that represents yet, so we multiply it by the conversion factor. I made sure that I put the feet across from the feet because that's the one I want to get rid of. So I get rid of it. All I'm left with is inches. X times 1 is just x, and I have inches up there. 27 times 12 is 324 inches. So now I take those two, since now everything's in inches, and I set them up because they are proportional. I need to solve for x. Cross multiply to get the equation. So when I cross multiplied, 36 times x was 36x. 324 times 2 was 648. 648 equals 36x. And then in order to solve this, we're going to have to divide by 36 because that's the inverse operation. And x equals 18 inches. So the height of the model is 18 inches. So here's your check it out. A model of a 24-foot tall bridge was made using a scale of 4 inches to 2 feet. What is the height of the model? I want you to attempt this. If you have to go back to the other example to walk through it again, do that. But when you get to this point, I need you to pause so that way you can try this. So go ahead and pause the video. Okay, so the model was 24 feet tall and it was made using a scale of 4 inches to 2 feet. So I'm going to take that scale and convert it with the conversion factor, which I found on the formula chart. 4 inches to 2 feet multiplied by 1 foot to 12 inches. I put the feet across from the feet intentionally so that way I can get rid of it. I leave the inches because that was the whole point in multiplying by the conversion factor. 4 times 1 is 4 inches. 2 times 12 is 24 inches. Now I'm going to do the same thing with the bridge. Change that to inches since I want the height of the model. x inches to 24 feet times 1 foot to 12 inches. This is going to change and allow me to cross out the feet and leave the inches. X times 1 is just x inches. 24 times 12 is 288 inches. So now I'm going to take those two, now that I'm done converting, and set them up into a proportion. That way I can solve for x. So 4 inches to 24 inches is equal to x inches to 288 inches. And you know how to solve this because it's the same way we've been solving. You cross multiply. That way you get your equation. 24 times x is 24x. 288 times 4 is 1152. Set up the equation. 1152 equals 24x. Divide by 24 because that's the inverse of multiplication. And you get x equals 48. So the height of the model is 48 inches.